Hello guys, welcome back to our YouTube channel. Today I'll be taking you guys through the introduction to trigonometry, and then we'll be talking about trig ratios and trig angles for our first session. So what is trigonometry? Trigonometry is derived from a Greek word which means what? Triangle measurement. So trigonometry is what? A branch of what? Mathematics that deals with what? The study of the relationship. So I think I should write that. Is the what? It deals with the study of the relationship of between what? Between the sides and angles of a right angled triangle. So when we say a right angle triangle, we are talking about a triangle like this, and the angle here is what? A right angle. So this is what? Trigonometry. And then trigonometry can be divided into two main branches. So we have plane trigonometry and we have spherical trigonometry. But I'll be focusing more on what? The plane trigonometry. And then also this definition limits to only right angle triangle, but I think we'll be doing more generalized one where we'll be focusing on triangles like that are not right angled and the rest. Okay, so some people don't really take note of definition, so in order to like actually succeed in maths, you need to be taking note of your definition. So kindly take note of these definitions. So the next thing we'll be doing now is to talk about what's the trig ratios. So what are trig ratios? Or trigonometric ratios. So we're just going to say trig ratios. So trig ratios are what? Functions. So these are what? Functions that we study around trig ratios, and they are what? There are, I think, 6 of them. So there are 6 trig ratios. So we have the sine, which in short we call what? Sine. We have cosine, which in short we call the cos. We have tangent, which we call in short tan. We have cosecant, which we call what? Cosec. We have secant, which is what? Sec. Oh, there's no T. Sec. Then we have what? Cotangent, which in brackets we call what? Cot. Okay, so these are the various types of what? Trigonometric ratios or functions that we have. So we will go and study how we can what? And then we'll talk more about these trigonometric ratios later. But for now, let's just focus on the first 3 and see how they are related to what? A right angle triangle. So when you have a right angle triangle, the angle here must be 90. So depending on the angle that's here, let's say this is alpha and this is beta. So we have this to be our hypotenuse. This can be what? Adjacent or opposite. I'll explain that later. And this can also be what? Adjacent or opposite. So depending on the angle that you are focusing on, let's say we are focusing on alpha. Alpha is opposite to what? This side, right? So you have opposite, and this will be what? Adjacent, and you have your hypotenuse here. If you are considering beta, this side will be what? Opposite, and this side will be what? Adjacent. So you should take note of that. So let's try and write the trigonometric ratio for this what? For this triangle for alpha. Let's write it for alpha first. So sine of alpha will be equal to, we know sine is equal to what? Opposite over what? Hypotenuse. Sine is equal to opposite over what? Hypotenuse. We can do that from the SOH-CAH-TOA. So sine opposite over hypotenuse. Cos is equal to what? Or cosine is equal to what? Adjacent over hypotenuse. So, but we don't know, we both have adjacent and opposite here, so we don't know which one is which. So for alpha, the sine will be equal to, this is the opposite, this side will be the opposite, and this will be what? This will be the adjacent for sine. So like for the alpha, so let's take cos alpha. Cos, so we are focusing on this, so this is the adjacent, and then we have the hypotenuse. So adjacent over the hypotenuse, and then we have tan of what? Alpha, which will be equal to what? So tan is what? Opposite over what? Adjacent. So tan will be what? Opposite over adjacent. You can do the same for beta. You can do the same for beta, but I guess similarly the same thing. So let's just write sine of what? This is beta. You'll get opposite over what? Hypotenuse. But this time the opposite side is what? Different, because we are considering this side now. So the opposite will be what? This side. This will be the opposite. So it will no longer be adjacent for this side. And this will be what? Our what? Adjacent. So our cos beta will be equal to what? Adjacent over the hypotenuse. And then the tan beta will be equal to what? Opposite over what? Adjacent. So this is how we define the trig ratio. This is how we define trig ratios. Okay. So now the next page we'll be talking about how we measure what? Trig angles. So measurements of what? Trig angles. And we'll talk about some special angles. The understanding of the measurements of trig angles is very, very important. So please take note. So let's say we have the Cartesian plane. You have your y, your x. Let me just indicate these directions. So to measure angles, we start from what? Your positive what? X axis. So this is your x axis. This is the positive side. and this is the negative side. This is your positive x, this is your positive y axis, and this is your negative what y axis. So we start from the positive what x axis in the anti-clockwise what direction. That's how what we measure angles in trig. But in bearing, you measure in the what? You start from north and measure in the what clockwise direction. But trig, we start from the positive x axis and measure what in the anti what clockwise direction. And there are some notations we need to know when it comes to the representation of sine, cos, and tan. In there, so we have what we call what quadrant. Okay, so this is one quadrant. This is actually the first quadrant. This is the second quadrant, and this is what the third quadrant, and this is the fourth quadrant. In the first quadrant, all the trigonometric ratios, the basic ones that we know here, are what positive. But in the second quadrant, only sine is what positive. So let me just put A here. And then in the third quadrant, only tangent is what positive. And in the first quadrant, only cos is what positive. That means that the rest are negative. So you have negative sine, negative cos here, and negative tan here. You have negative sine here, negative cos here. You have negative sine, negative tan here. That's what that means. So we measure angles from the positive x-axis in the anti-clockwise direction, and this are what happens doing what when the angles are in this quadrant. But let's see, why are these things like this? So let's say we have, let me draw our quadrant. Let's say we have an angle in this quadrant, this angle theta. Let's represent our opposite with y and our adjacent with what? X. The hypotenuse, let's just call it what? R. Our sine theta will be equal to what? Y over what? R will be equal to opposite, and the opposite is y over the hypotenuse R. Our cos theta will be equal to what? The adjacent, which is x, over what? R, which is what? The hypotenuse. Tan theta will be equal to what? Opposite over what? Adjacent x. Okay. Now let's consider the same thing, but this time our angle will be in what? The second quadrant. Let's say our angle is here, making contact with the positive what? X-axis. Right? Here we'll have y, and here we'll have what? X. Right? But here will be negative what? X, because we are in what? The negative what? X-axis. Right? We are in the negative x-axis, so here will be what? Negative x. Here will be positive because we are still in the positive y-axis. So let's see what's happened. Our sine theta in this case will be equal to what? Opposite, which is this, over R, which is what? Positive. Well, let me just write plus. Cos theta will be equal to what? Negative x over R, and this is what? Negative. Our tan theta will be equal to what? Y over negative what? X, and this is negative. Now so let's look at what happened. So let me name this first quadrant, second quadrant, and what happened in the third quadrant when we have an angle in the third quadrant. And just name this one alpha. This will be our R. This will be our what? This is in what? This will be our x, but it's in the negative x axis, so it's negative x. This will be our y, but it's in the negative y axis, so it will be negative y. So sine theta will be equal to what? Negative y over what? Actually, it's sine alpha, okay? Negative y over r, and this is what? Negative. Cos alpha will be equal to what? Negative x over r. So this is also what? Negative. Tan theta will be equal to what? Negative y over negative x. And this will be equal to y over x. And this is what? Positive. Let's look at what happened in the fourth quadrant. This is your y, but it's negative y because it's in the negative x axis, and this is your x. Our sine theta this time will give us what? Negative y over what? R. This place is r, don't forget. Negative y over r, which is what? Negative. Our cos theta will give us what? X over r, which is what? Positive. Tan theta will give you what? Negative y over what? X. And this is what? Negative. So that's why we say that's what? So that's why we have these conclusions that in the first quadrant, all the trigonometric ratios are what? Positive. Okay, the angles of all the trigonometric ratios are positive. And then in the second quadrant, only sine is positive. From here, the second quadrant, only sine is positive, cosine is negative, and tan is negative. In the third quadrant, sine is what? Negative, cosine is what? Negative, tangent is what? Positive. In the what? In the fourth quadrant, only cosine is positive and the rest are negative. So this is the basic idea of why we, so to represent all this, we draw, for your understanding, sometimes people use CAST to represent them, and they start from here: C, A, S, T. So that's CAST, to represent like the ones that are positive, so that when you remember this, you know the rest are what? Negative. Okay, so now let's move to some special angles that we work with in trigonometry, and that will be our last thing we'll do for this video. And actually, we'll compute some of the angles and see